Every single day, your computer is pulling off this incredible magic trick right in front of your eyes, and you probably don't even notice. It's a trick that lets you do more, run more, and really push your machine to its limits. So today, we're going to pull back the curtain on that trick. It's called virtual memory.
Okay, let's start with a puzzle. And I know you've run into this. Picture this. Your computer has, let's say, 4 gigabytes of physical memory. That's your RAM. But you, being the multitasker you are, have your browser open, maybe a game, and some other software running. Altogether, they're demanding like 7 gigabytes. I mean, logically, your computer should just give up, right? Crash. But it doesn't. So how is that even possible?
Well, the answer, my friend, is virtual memory. And no, it's not some secret extra hardware you didn't know about. It's actually just a clever illusion. It's a piece of software wizardry that your computer's operating system pulls off. Your OS basically lies to your programs. It tells every single one of them, hey, don't worry, you've got all the memory in the world. It creates this virtual idea that there's a massive, almost infinite amount of memory available.
So how does the OS actually create this illusion? How does it pull it off? Well, the secret is surprisingly simple, actually. It just borrows a little chunk of your much bigger but way slower storage drive, your hard disk or SSD. And it pretends that little chunk is just an extension of your super fast RAM. And this special reserved area on your disk, that's what we call swap space.
Okay, so we've established that the OS is using this slow storage to pretend it has more fast memory. But how does it actually manage all that? I mean, moving data between two totally different kinds of hardware, that sounds complicated. Well, the core mechanism, the real secret sauce behind this whole magic trick, is a process called swapping.
Right, so swapping. It's kind of like this constant two-step dance happening in the background. First, when your actual fast RAM starts to get full, the OS gets clever. It looks around for chunks of data that you're not really using right now, like a browser tab you haven't touched in an hour. It takes that inactive data and moves it out of RAM and onto the slow disk. We call that swap out. Simple enough. Then what happens when you decide you need that tab again? The moment you click on it, the OS goes, whoops, need that back, and it grabs that data from the disk and shoves it right back into RAM so you can use it. And that, you guessed it, is swap in.
Okay, I get it. This might still feel a little techie and abstract. So let's make it super, super clear with a really simple everyday analogy. I want you to imagine your computer's RAM is like a small study table. It's right there in front of you, so grabbing a book off of it is super fast. But, it's a small table. You can only fit a few books on it at a time. Now, think of your hard drive's swap space as this huge cupboard in the corner of the room. It's got tons of space, for sure, but it takes a bit of effort to get up, walk over, and find the exact book you need. So the books you're actively reading, they're on your table, your RAM. Everything else, it's stored away in that giant cupboard, your disk.
And the whole process works just like you'd expect in real life. Think about it. Your table is full, but you need to start working on a new book. What do? You look at the books in your table, find one you probably won't need for a little while, and you put it back in the cupboard to make some room. That's a swap out. And then a little later, you realize you need that book again. So you get up, go to the cupboard, and bring it back to your table. That's your swap in. See? It's really that intuitive. All right, that study table analogy really hits the nail on the head, doesn't it? So let's take that idea and apply it right back to our original problem with the computer. And here we are, right back where we started. We've got the physical reality, only 4 gigs of RAM. But our demand is way up at 7 gigs because we're trying to run a browser, a game, and a coding program all at the same time. The demand is just way bigger than the supply. So just for a second, imagine a world without this swapping magic. What would happen? Well, the instant you tried to open that third app, the one that tipped you over the 4 gigabyte limit, your computer would just say no. It would throw up its hands and you'd get that dreaded out-of-memory error. The program would either refuse to launch or everything would just crash. And this is where you see the core trade-off. Without virtual memory, you just hit a hard wall. End of story. But with it, the programs actually run. You can have all 3 open at once, which is amazing. But there's always a catch, isn't there? Because moving all that data back and forth from the slow disk, from the cupboard, takes time. The whole system can sometimes feel a bit sluggish. You know that feeling when you switch back to a big program you haven't used in a bit, and your computer just kind of freezes for a second or two before it wakes up? That little bit of lag? Yeah, that's exactly what a swap-in feels like in the real world.
That's your OS frantically running to the cupboard, grabbing that program's data, and throwing it back on the study table for you.
Okay, let's do a quick recap of the crucial points here. Virtual memory? It's that amazing illusion of having way more memory than you actually do. It works by using your hard disk as a kind of extra but slower RAM. The whole process of moving the data around is called swapping, and the best way to think about it is that study table, your RAM, and the big cupboard, your disk. And the big takeaway? The benefit is you get to run huge apps all at once. The cost? Well, a little bit of potential slowness.
So when you boil it all down, the most crucial point is this. Virtual memory is really all about a fundamental trade-off. Every single day, our computers are making a choice. They're choosing to give us more space over pure speed. It's a deliberate design decision, and honestly, it's what makes modern computing even possible. And that kind of leaves me with a final thought for you to chew on. What trade-offs, big or small, are you making in your own life every day just to get things done?